Alright, what's up everybody, it's your boy DudePlays here, and I'm back with some more YouTube reaction videos for you guys. So today I'm checking out Steam is breaking the hardware barrier. Now before we get into this, don't forget to comment, like, share, subscribe, turn on post notifications, socials are in the description. With that being said, let's get into it. Full screen.
What if I told you that the architecture barrier of PC gaming has finally been broken? For decades, if you wanted to play the biggest games on Steam, you were locked into processors from Intel or AMD. But now, everything is changing. We just saw Cyberpunk 2077 screaming at over 200 frames per second on an ARM-based system, the same type of architecture that powers your smartphone and the latest ultra-efficient laptops.
Yeah, so where it pertains to ARM, you know, slowly taking over gaming. I wouldn't say taking over, but you know, it's definitely prospering, especially with Valve's new translation layer FEX. They've been working on it since 2018. It's now 2026. For reference, I graduated high school in 2018. It's been 8 years, almost 8 years. I think they started in July. I graduated June 2018. Wow, a 2-year reunion would be in 2 years. 10-year reunion would be in 2 years. But anyway, I'm going off topic. So, and we have like things like GameHub, but I'll get more into that. I don't want to spend too much time talking here. Let's let it play out, especially with, you know, ARM and their M series chips, which are ARM processors. But let's continue.
2026, just a few days ago, Ubuntu dropped a bombshell by releasing an experimental Steam Snap for ARM64. This is a massive tech stack that bundles Steam with a translation layer called FexEmu. Now, to be clear, those 200 FPS results were achieved on high-end NVIDIA Spark hardware, but the fact that it's running at all through emulation is a monumental feat of engineering. So why should the average gamer care about an experimental Linux package? And well, it's because it represents the future of gaming. We've seen the promise of ARM, silent devices, and incredible battery life. By perfecting this translation layer, Ubuntu and Valve are proving that.
Hold up. So this is the game on modified x86 software. Well, the game is made for PC, x86, specifically Windows. Base libraries, Unity, Vulkan. So this Vulkan we know is the graphics API. Unity would be the game engine, and then base libraries, I'm guessing, is like code related stuff. ARM hardware in x86 disguise, kernel compatibility layer, ARM Linux kernel, recompiler. So this is the thing that's actively translating the code in real time from x86 to ARM, because different instruction sets, so that has to be done. Threads and signals, file system, system calls, GPU driver, ARM CPU. So this is the tech stack, the layers of abstraction to get this to run on this. System calls would be like specific functions that the game would ask the system to run, but because it's running on a different OS, you'd have to use the Linux equivalent of that system call on Windows. But anyway, I'm not going to get too deep into that. Let's continue.
The hardware you choose to play on won't matter anymore. In this deep dive, we're going to look at the magic of FexEmu, the secret reason Valve is pouring money into this project, and how this is setting the stage for a revolution in gaming. Whether you're a Linux enthusiast or just waiting for the Steam Deck 2, this is the story of how the walls of PC gaming are finally coming down. To understand why this Ubuntu news is so important, we first have to understand the architecture barrier of computers. For the last 30 years, the PC gaming world has basically just spoken x86. Almost every game ever made was written specifically for x86 processors. ARM, meanwhile, is the king of efficiency, but because the instructions are different, an ARM.
Yeah, we know this. ARM is power efficient, so it's good for sleep modes, low power situations, battery life. Really, that's really what you'd want the ARM for. The current handheld PCs can't do sleep downloads. Even the update that they released for Steam Deck, I think like a month or two ago, that just shuts the screen off and limits TDP, but it's still very much on. It can't do sleep downloads like your traditional iPhone, iPad, or ARM-powered mobile device. So it would have been cool to have like that ARM chip, like a secondary ARM chip in these PC handhelds, but that would just draw more power. But I could only ever see it being on when you're downloading games while playing a game, and then also running while you have downloads active. Then it would trigger the ARM processor. But anyways, that would increase costs too. But back to what I was saying. What was I talking about? I don't remember.
ARM chip literally doesn't know what to do with a Steam executable, or at least it didn't before. The core of this breakthrough is FexEmu, a project funded by Valve for nearly a decade. While many people are familiar with emulation through things like playing old Nintendo games on a PC, Fex is a binary recompiler. As developer Tony Wasurka explained in his presentation on breaking architecture barriers,
I'm looking at this, what seems to be assembly code. This is an interesting breakdown. Look at this. So function push. This looks like assembly code. Yeah, obviously that's not machine code because it would be like ones and zeros. Yeah, this is definitely assembly code. Push, move, push, move. Wow, this is interesting. I don't even know what to say. Let's let it play.
Emulating an x86 CPU is monumental. x86 has thousands of instructions.
It really is.
Some estimates say up to...
And I imagine ARM has far less, because x86 is designed for high performance. And because of that, I feel like I'm too close to the mic. And because of that, naturally high performance requires high power draw. So it's producing a lot of heat and drawing a lot of power. So x86 isn't really fit for handheld devices. I mean, as of recently now, we have the new handhelds, but even something like the Xbox Ally X, for example, that can draw like tens of watts just playing a game. Obviously, like the AAA games, if you're playing something 2D, then it can be single-digit watts. Especially with the Z2 Extreme, because that's more efficient than the Z1 Extreme. But, alright, let's use Cyberpunk as a base comparison. The Steam Deck, we use 23 to 27 watts. The Switch 2, which is an ARM chip, uses 9 watts. The Switch 2 literally uses 9 watts to play Cyberpunk. That's incredible.
To 6,000 unique variations depending on the extensions used.
The fact is the x86 instruction set is huge. And we're not talking about like tens or hundreds of instructions, but depending on how we count and how many of the different instruction extensions like SSC and SSC2 and whatnot you count in, you can reach up to thousands of...
And SV2.
It's like 6,000, for example.
Fex doesn't just guess what the game is trying to do. It takes the x86 assembly code and recompiles it into an intermediate representation. This IR is a neutral ground where Fex can optimize the code, eliminating redundant steps before finally outputting native ARM.
And then if it's reducing redundant steps, wouldn't that mean less code being executed, meaning higher performance, more efficiency? Unless, of course, that redundant code is just... Hold on, let me think. That redundant code is just... I don't know, yeah, I would think. Because if it's removing redundant code, that means it's not running that redundant code, which would mean less CPU cycles, which would mean higher performance. But then it would cancel out because there's the CPU time needed to translate it. So it's still a loss. It's still an overhead, CPU overhead. Anywho.
So we can take our internal representation and make sure, like, do things like constant elimination, for example, to make sure that whatever code we use to ultimately generate ARM code is as minimal as possible.
But this optimization is critical because, as the Fex team says,
we still need to make sure that it all runs fast, because we don't want to have a slideshow. We want to actually use the applications that we emulate. And for that, we need a fast implementation of this whole thing.
This is obviously very important for gaming because you want the games to run,
Very
but
complex.
also run well. By using this multi-step translation process, Fex can get remarkably close to the original input size, keeping the overhead low enough to run demanding 3D games. You may have even already tried out Fex yourself without even knowing, with things like the Game Hub. One of the most
Let me go back real quick. That's such a crazy company name. Guangzhou Chicken Run Network Technology Company Limited. That's such a mouthful. I can understand, it's probably a Chinese thing. But Chicken Run, how does that? What's the correlation there? Why call it Chicken Run? Whatever, it doesn't matter.
Fex yourself without even knowing, with things like the Game Hub. One of the most fascinating and difficult parts of the Fex project is something called the memory model. This is a reason many emulators fail. In his presentation, Tony used a brilliant example.
We have 2 threads in our program, and the first one is just trying to get the second thread to compute a result.
Imagine a program where one part of the CPU calculates a result, 42, and another part waits for a done flag to flip to 1. On an x86 chip, you are guaranteed that if the done flag is 1, the result is ready. On ARM, however, the CPU decides to reorder those instructions for efficiency. It might flip the done flag.
So ARM isn't necessarily sequential execution like x86? That's what I'm getting?
Before the result is fully written to memory. This creates a race condition where the program sees the flag, checks the results, and gets a 0 instead of 42.
This is extremely difficult to resolve from an emulation perspective because we still need to adhere to the x86 semantics.
Fex has to solve this by using half barriers and smart heuristics. For example, they discovered a specific pattern used by almost every Unity game, a 61-bit circular buffer. By creating a specific hack or heuristic for this pattern, Fex can disable expensive memory checks for everything else, providing a
massive performance boost for those Unity games. It's a bit of a hack, but just because it so consistently works across such a wide range of the library, it's really worth it in this case.
So FexEmu is the engine powering all this, but how do you, the user, actually get it running without a PhD in computer science? This is where Canonical's new Steam Snap comes into play. Now, to be clear, Ubuntu has specifically said this isn't directly partnered with Valve, but obviously they are using Steam, Fex, and Proton, all Valve projects, to make this work. Previously, setting up Steam on ARM was a nightmare. You had to manually install Fex, set up x86 root FS, and then figure out how to bridge your graphics drivers.
And as he mentions that, and that's a nightmare, I imagine. Imagine just like writing all of the source code for this stuff. My God, I respect these people so much as a computer scientist myself. I am nowhere near these people in terms of skill. And I shouldn't be at my age. But anywho, yeah, what I was saying was, it's a good thing they ported SteamOS to ARM for the Steam frame. So that's no longer an issue. So that eliminates so much issues there. Because imagine if Valve made the Steam frame run x86 SteamOS on the ARM Steam frame and then still has to do the translation, not just for the software, but for the OS itself. That's too much. They had to port that, and they probably started in 2018. So that's 7 years. Imagine rewriting an OS for a new architecture. Or for a different architecture, because ARM isn't new.
Ubuntu has
Crazy.
fixed this by using the snap format. Now, you might be wondering why a Linux distribution like Ubuntu is working so hard on this. And the answer lies with Valve. It is no longer a secret that Valve is funding FexEmu development. Tony explicitly stated in his talk,
We're actually paid to improve Fex, so none of this would have really been possible without Valve's monetary support. So thanks again a lot for that.
think about that. Valve already has the Steam Deck, which uses an AMD x86 chip. So why invest millions into an ARM translation layer? And the first answer is the Steam Frame. Valve's new headset, the Steam Frame, runs on an ARM chip, similar to the processors in the Meta Quest. To make a VR headset light and battery efficient, you almost have to use ARM. But Valve can't launch a VR headset with 0 games. So by funding FexEmu, Valve is ensuring that on day one, their ARM-based headset can run the entire existing library, but it's not just for VR. It's also about the Steam Deck 2 and any other future hardware, even from other manufacturers.
Yeah, that's the thing too, because when they perfect these translation layers, because it's not just with Steam Deck, we know it's an x86 chip, so it's just translating system calls and graphics APIs and stuff like that. System calls, blah blah blah. So it's not just Proton Windows to Linux. There's no CPU translation going on because they're both x86 chips. The Steam Deck, we know this. So it's Windows to Linux translation, essentially, compatibility layer. And now Steam Frame is ARM to x86. Or I should say x86 to ARM. Yeah. No, it's converting x86 software to ARM because the Steam Frame is ARM. And it still has to do the OS level translation as well. So that's 2 layers of translation. That's increased complexity. But we also have Android translation. So we're translating ARM to ARM. But this time it's Android to Linux. And it's the same CPU architecture, so it's ARM to ARM, just like how the Steam Frame is x86 to x86. So on that level, it's just OS level translation. So we're getting Android games on it too. Beautiful. I can't wait to sideload APKs, Netflix, Discord, Spotify, everything. Yeah, let's continue.
The efficiency of ARM chips is now rivaling and in some cases beating what Intel and AMD can do in a handheld power envelope. By perfecting this translation layer today, Valve is removing the architecture lock-in. They are making it so that in the future, they can pick whatever chip is the most powerful and efficient, regardless.
Imagine how good this translation layer is going to be in 10 years. Proton is it's basically damn near perfect at this point. Imagine how Proton is going to be in even 5 years, much less 10. The only limitation we have with Proton now is the anti-cheat, and it's not impossible, it's just devs need to enable Linux support. Enable the anti-cheat for their games for Linux. They choose not to, but it's very much possible. I don't know how they're going to resolve that. We'll see how it goes with time.
x86 or ARM, and your games will just work. In recent interviews, Pierre, a Valve employee, has said that they are waiting for the right SoC landscape to emerge, suggesting that the superior battery life and performance per watt of ARM could be exactly what they need for a true next-gen Steam Deck 2. Now let's look at the actual numbers from this news and how Steam is running on ARM, because that is the most exciting part for any gamer. Canonical did their primary testing on the NVIDIA DGX Spark. This is a high-end development platform, but the results prove that the software stack is ready for the big leagues. For example, Cyberpunk 2077 achieved 200 plus FPS using DLSS via Proton. For Counter-Strike 2, it was described as smooth with no notable performance issues in 2+ hour sessions. There was even Hollow Knight Silksong, which yes, they tested it and described as very smooth. Dota 2 and Portal 2 had no notable issues, and they were running like native apps. There's even multiple other games that they tested, which you can check out in this list. However, we need to have a reality check. This is an experimental beta. If you are on a Qualcomm Snapdragon X laptop, there is a known issue preventing the Steam client from working properly right now. Canonical is investigating this, but it's a reminder that ARM on Linux is still in the early phase, and will really only just get better from here. If you have an ARM64 device running Ubuntu and you want to join the beta, the process is pretty straightforward, but you must follow the order. The first time you launch a game, Fex has to build a code cache. This can take up to 10 minutes, but Fex is essentially pre-translating parts of the game to disk so that the next time you play, it loads instantly and
Kind of like shader compilation on Steam Deck. I mean, it happens even on native hardware, because if you're playing something like, I was playing God of War Ragnarok on my gaming laptop here a couple hours ago, and even Marvel Rivals, it shows you the shader compilation little notification on the screen and the percentage of the shaders that have been compiled. And ideally, I just hit the mic. I don't know if you heard the sound. Ideally, you know, it would be best to wait until the shader compilation is complete, then you launch the game, which I do sometimes. I probably should do more often. But anywho, this sounds a bit different because it sounds like it's actually compiling game code. So I might rewind and listen to that again.
This can take up to 10 minutes, but Fex is essentially pre-translating parts of the game to disk so that the next time you play, it loads instantly and doesn't stutter. And now you're able to try out Steam Gaming right on ARM64.
During that first run, Fex will keep track of all the blocks that have been executed, all the locations in the code that the game was trying to run. And on the next run of the game, Fex will pull ahead all of the compilation processes that previously were done on the fly, and it will collect one huge binary and save it to disk so that subsequent runs of the game do not need to use the recompiler anymore in a lot of cases.
So for those of us following the progress of Linux gaming, as its percentage continues to go up with Steam, this is the beginning of a new era. We are
You know, I really want to see it get so good to the point where the other developers are like, yeah, we have to support this now. We have to support, because with them, you know, having different systems, them having ARM on the Steam store, I mean, well, not on the Steam store, but, or maybe that will come eventually, but them allowing people to play Steam games on ARM hardware is going to widen the net so much. And I feel like other developers are going to be like, wow, look at this. And they're going to be intrigued, and then market share is going to go up for Linux, SteamOS, all of that stuff. It's going to get more popular, and then more people will be enticed to let the floodgates open where it comes on to anti-cheat support. That's my biggest thing with SteamOS.
away from being locked into a specific
Rockstar took away my ability to play GTA Online portably. That's really what I'm speaking about when I talk about that stuff.
type of processor. This Ubuntu Steam Snap is the first time a major OS has handed users a one-click solution to the ARM gaming problem. It brings together Valve's funding, FexEmu's technical brilliance, and Canonical's packaging. As Tony Wasurka finished in his talk,
You can start to see a pattern. x86 simulation isn't magic. I mean, maybe it is. But it's also a lot of work, so sadly.
that work is finally
Understandable.
paying off, and gamers are now getting to try it. We are seeing a future where your OS choice like Ubuntu and your storefront choice like Steam are more important than what kind of silicon you are using. The architecture wars aren't over just yet.
Yeah, it's not over yet. We need another 5 to 10 years to perfect this. But you know, that's something I always used to think about as a child, before emulators came up. And I'm like, wow, this game is only available for this platform. And I used to think to myself, why is it that it only runs on that hardware and not anything else? I know it obviously has to do with the code and the binary and CPU architectures. Even as a child, I understood that stuff because I'm a relatively tech savvy guy. Nowhere near these people's level, like I said earlier in the video, but I understood that. And then I became privy to emulators, and I'm like, wow, you can play games from other systems now, Nintendo DS, PSP, PS2, blah blah blah, all of that. And fast forward all of these years later, and here we are, and the revolution, the lock, the architectural lock is being busted. And yeah,
But the walls
I'm
are
here
definitely
for it.
coming down, and Valve's projects are right at the center of it. Don't forget to like and subscribe to stay updated on the future of Steam gaming.
All right, yeah, that's it, guys. That was my reaction to Steam breaking the hardware barrier. Hope y'all enjoyed. I will see y'all in the next one. Goodbye.